Okay, so howdy. In this stream, I'm going to try to create a tensor object as fast as I can I'm going to try to create a tensor object as fast as I can in C, specifically for the borland C compiler for Windows 1. So let's do it. Let's do this. There we go. Okay. Okay, so let's put the boilerplate. And then I saw someone do this. But I'm not really sure if that would work. Okay, it built, and as you can see, we actually can see that, well, obviously haven't used those parameters, so whatever. In fact, I think I can just do that. Yep, we can. And in fact, we can do this. And isn't that so cool that we can do this in Windows 1? Like, we just run it, and it's so cool. It is such a cool thing. Anyway, let us see what to do now. I'm just checking the stream up here. Here we go. Okay, cool. We're back. And now you guys may be wondering, what is a struct? Oh, sorry, a struct. What is a tensor? A tensor, all a tensor is just a memory structure. It is a memory structure specifically of an n-dimensional data array. So it could be an n-dimensional shape with, that's all it is. And then it's up to you to figure out how to manipulate said data. So I would do struct tensor, right? So then you would do dimensions. Number of dimensions. And there's no like right or wrong way to implement these. And then shape would be ready to store size of each dimension. What is in the E? Oh, it's just edit. Okay. Some options. Oh. That's fun. Oh, isn't that cool? Cool. And then let's just save that. Errors. You know what? Declaration needs type or storage class. So apparently this does not exist. Okay, let's try this again. Cool. All I needed was just I just needed to fix the comments. I think this is this KNR? No, I think this is ANC. But anyway. Okay. Now how will we need to create a tensor. So let's do that. So let's do tensor create tensor, and this will be int dims int shape. And then cool. Okay. Gotta make it nice. Let's just do this. Make it nice. Tensor goes cast it to tensor pointer. Okay. That makes sense. Okay. Tensor dims equals dims. Makes sense. Tensor shape equals, and then int rightcast and int alloc dims times size of int. Okay. So cool. And then let's do int I. For I equals 0 less than dims I plus tensor shape I equals shape I. Cool. Shape equals 1. Nope. For I equals 0 less than dims I plus size times equals shape I. And then tensor data equals int malloc size times size of int. Return tensor. Okay, it is compiled. Cool. Now, let us create a tensor. Shape equals 2, 3. Let's do a 2 by 3. Cool. let us do tensor. Tensor equals create tensor to shape. And if we remember, create tensor is number of dimensions and your shape. So the number of dimensions is 2 because shape is too long, right? So 1, 2. And then down here, free tensor, because I want to free that. Although I should do a free tensor. And then of course here free tensor. And then tensor, free tensor data, free tensor shape, free tensor. And I like that better. I don't like the other one. Okay, now okay. Cool. So I think we've created a tensor now. Now let's try to set an element. Okay. Okay, so how do I do this? Void set element. Tensor, right? Indices. Nice indices. Okay, that looks about right. Equals tensor gives -1 greater than equal to 0 minus then this is index plus equals indices, right? It's just really weird stuff happens. Time stride, and then each time you stride so shape, remember, is the shape go up here. Shape is the array to store, right? So you have to go through each. You have to go through the array to store your stuff. And then tensor, you're doing a multi-dimensional array in a single dimension. It's just easier that way. And then once you have, basically what you're doing is you are taking your tensor and your indices, and you're going to jump to the place in the multi-dimensional array where you want to get set the value, and then you set that value. That's all it is. It's super easy. It's super simple. It's a very interesting, I think it's a very efficient way of storing things, but just know that it's going to be difficult to well, the bigger the tensor, the longer it's going to take, essentially. So that is something to know. I think F2 is save, yeah. And then looks good. Okay, so, oh my god. So then I want to set create a tensor. Now I want to get my index, create my indices here, set my indices, and then set element. So if you look here, your indices is like where do you want how far in the first dimension, how far in the second dimension, and your number of indices needs to match the number of dimensions you have, or at least up into the point, right? So it does have to match the number of dimensions you have. See, this is very type unsafe, so if you wanted to do something better, you can certainly do that. Pretty interesting. I could definitely see myself making a C library and a C object out of this. I think that'd be fun. Let's do that. Let's do a C object conversion after this to how to create a tensor object in C. That'd be fun. Anyway, so I've created the tensor. Let's do int element 1 element foo equals 1 2. Okay. The reason I'm declaring things first is because I'm not quite sure how this compiler works, and I just don't want to deal with errors. Set element let's do 42. Okay, let us compile that. That is compiled. And then let us do the last one that we're going to do today, and that is going to be void get element. Okay, and get element is going to be essentially the same thing as set element. If I can type. Oh my god, I don't know how to get rid of that. What am I doing? Tensor data. Sounds about right. And then value equals that. And then here I can say and then here okay. Returned value is 42. I have successfully created a tensor in C in Windows 1.0 using Borland C compiler. That's pretty awesome. And I'll see you later on a different lab. live stream if I don't get to another video first.